¿Funciona?
Yes, we're live.
Yes, we are live. Sorry,
Okay.
didn't realize.
We are not, I'm not the best producer, so I'm not sure. I couldn't make the intro shorter. Okay. Hi everyone. Thank you for joining. I'm RJ, one of the founders of Align. I'm here with Diego and Mauro, also co-founders of Align. Um, and for those who don't know, we take a few minutes every Monday to talk about the project, give a few updates on the engineering side, on the product side, and our view on certain topics in the industry. And if we have any particular news that we want to share with the community, we will say them here, and you can see our beautiful faces explaining stuff and addressing your concerns. So, I think what we will do today is the following. We don't have a lot of news from the Ethereum community or project in itself, and Align is still working on improving the aggregation mode and some other stuff. So today is going to be a shorter stream. So what we will do is start with Mauro, giving his usual update on how the engineering team is doing and what's the latest on our products. And then I can briefly review again. Maybe I would repeat some stuff that we said last week regarding our roadmap and our main priorities. And we can speak with Mauro and Diego about how we see Ethereum. I think the only thing that changes is that the market is changing, and maybe we can give our opinion on on how Ethereum is handling that stuff. So, Mauro, do you want to start?
Yes, so as you said, like we were mostly working on, and we are still mostly working on aggregation mode. The team is now doing some examples so you can have some base for you to build stuff on top of aggregation mode. Should be finished during these days. The other things are more technical. There is a thing called deterministic builds on most of the RISC-V VMs. What they try to achieve is that the compilation of the program is always the same. So in that way, the verifier, for example, in Ethereum, can make sure that the proof came from the right program. Because if the compiler swaps something or does something a little bit different, it is another program, and so the proof, even if the logic is the same, the proof is from another program. Like this could be just enable optimizations. You can imagine that, but any small change can change the program. So we had a thing called deterministic builds or deterministic compiling, which is just like having an environment to have a very repeatable way to compile everything, and in particular the programs used for the aggregation mode. Then there are some small upgrades on Explorer to show like which proof of the aggregator came from SV1 and which one from RISC-0. Yeah, I think that's it. There are some small details, like we changed the backends of the Merkle trees to the ones in Lambda words, in particular for the aggregation mode. So that's similar to what we have in past mode. And hopefully with the app, you have some examples on how to use it and how it looks and everything.
Yeah, and the last thing I would say is that we having been a little more strict with some operators lately, making sure people that join the network meet certain requirements in performance and responsiveness. We are probably going to, yeah, we did some clean testnet, and we're probably going to do some cleaning in mainnet as well. I think we'll communicate the communicate when we do that publicly, so yeah, people using the network are aware of this. But it's everything is going to be very easy to check and see through the Explorer. Yeah, I think that's basically it about engineering. And in terms of the product, we're still working on some of the designs and requirements we want for certain things. We do know that after the aeration mode, the roll-up as a service is going to be uh, like it's already one of the main priorities and it's going to continue to be the main priority. At the same time, we'll continue exploring more the wallets and understanding what features people will want. Um, I think that this is going to be really important with all the demand we're going to see with stablecoins. We are researching a lot of these things. I haven't seen people in Twitter talk too much about this, but I think it's pretty obvious just to see and realize that the latest news on Stripe and the people that Stripe invited to their keynote shows that we are in a new era. And I don't think the market, and especially people in crypto Twitter, have realized yet the importance of this. One of the biggest internet financial service providers just said like, I'm going to use stablecoins for almost everything. I don't think that's a minor thing. And they invited Mark Zuckerberg to stage. It looks like Facebook is very interested in resuming their crypto efforts. So that will create demand for different type of infrastructure and products. And we're studying all of that and trying to see if there's anything that will change our thesis. So far, I think it's very aligned to what we have been saying. And if we need a lot of stablecoins and transfers, people will need a place to, they will need infrastructure that can handle that traffic. And the only way to scale blockchains to that amount of demand over the internet is with rollups. So I think it's very much in line to what we had in mind. Um, and also, all of this stablecoin demand will probably demand a lot of more bridging and interoperability and wallets. So I think we are in a very good position to benefit from all of this. I think the most important thing will be to learn from all of the things that are going on and try to get people to build with the tech and see what happens. But I think that's something that we have been discussing a lot internally, and I haven't seen a lot of discussion publicly about it. Uh, and I think it's very good, not only for Line, for Ethereum. Like this is actually a very, very, very bullish news for Ethereum and crypto in general. So that's something that I think everyone should to have in their minds. And yeah, whenever we have all of these MVPs and everything, we'll start sharing it. And also, as Mauro mentioned before, I don't remember if we said it last week, but there's the Ethrex team already working on the integration with Aligned. They share a public update, I think, today, and they mentioned that. So once that integration is done, we'll be able to share more with you. So everything is in line to have to be able to launch rollups on top of Align very easily in the near future. Diego, do you want to say anything about the subjects?
Yeah, no, but something that is also important, there has been like some research lately in um, proof systems and new CKVMs. Right now, as we are speaking, CK Summit 13 is being held in Toronto. Boris
Oh,
from our team is there. So if you want to talk, you can look for Boris in CK Summit. Um, I think there are very cool talks. For example, there is one on lattice fold, which is really interesting because this is a construction for a folding scheme using lattices which are post-quantum secure. Um, Maybe the CK torch looks also interesting. Risk Zero is going to be presenting Risk Zero VM version 3, which is a multi-proof system CKVM. I think this is something really cool because I don't know, you can have a bug in your proof system and it can be exploited, but if you're using several proving backends, then in order to break security, if at least two proofs have to pass, you have to find somehow a kind of correlated bug, which may not be easy to exploit. So I think this is something really interesting. Also, there is another talk on um, twist and shout and a new development on Jolt. Um, then, for example, there is another one that is very interesting by Ulrich and Yuval from Ingonyama. Ulrich is from Starkware about Laurent Starks. Uh, then there are like some comments on Ligerito. And I think one that at least I find very interesting is programming venues with M3 arithmetization. This is a new type of arithmetization that uh, the reducible team has been developing. It's really interesting because it changes kind of the paradigm that we are using. Uh, Basically, the idea is that you put things into channels and then you have to balance these channels. It's very different to how, for example, air or Plonkish arithmetization works. I think there may be like some hidden trade-offs, but we saw that Polygon and Irreducible released a new VM called Petra. It works on a different kind of thing. So I don't know, that looks promising. I've been looking at the code base and everything, but it seems that the main idea behind M3 is avoiding commitments to polynomials you can calculate from other polynomials, which they term, of course, virtual polynomials. And this is a strategy, for example, that was used in the GKR protocol for log apps. The idea there was, okay, I don't want to be committing to the polynomial of every layer because in general committing is expensive. So I think that in this case, the M3 arithmetization takes this approach uh, to the extreme, and so they try to avoid committing to as many things as they can. Um, so I don't know. It looks promising. We haven't done any performance analysis or anything yet, um, but it looks like really interesting. And I don't know. Maybe we have to see. For example, in GKR, we had this new analysis on the security showing that for certain circuits, you can break the security of GKR, and that's because not everything is committed. So I don't know. So we still have to analyze, but I think it's cool to have like new different formats of PMs working with different proof systems. And besides, the good thing is since this works on venues, no elliptic curves, which means this is post-quantum secure. So I don't know. It's interesting to have a new VM.
Arshai, you're mute. If I don't know if you were talking here.
Yes, skill issue. Very embarrassing. What I wanted to say is that I think what Diego is mentioning, the most important thing for those who are not very technical is there are many people in the industry working across different CKVMs with different new techniques, trying to make things faster, and in some way also some not only more efficient and faster, but also safer. So for the industry in itself, what I think is very interesting is okay, if you have so many teams, most likely at least one of them will find a breakthrough in the next 12 months that will make the whole thing go faster and even better for everyone. And everyone will tend to start using the tricks, the new tricks and technique from the other one. So everyone will improve with the new findings from all of the others. So I think in general, for people that want to use CK, particularly in Ethereum, All of this, there is a lot of people that raise a lot of money, and that they have really smart people in engineering and in research, is going to be beneficial. The issue is these things start usually take time, but we're in a moment where things are accelerating a lot. There are many new teams, and the tech is getting really good, and that has been what we have been saying for a long time. We don't know which of the CKVMs is going to be the best one. We just know that all of them are going to be way easier to use. They're going to be cheaper and faster, and that we want to offer that for people that want to develop on top of Ethereum using CK. So from our point of view, we'll be pragmatic. We'll just try to integrate with the VMs that we see that are robust and that can offer a good experience and are also fast. And the idea is to offer as many of them and try in the future to offer ways for them to access maybe even multiple proof systems. So if you want to have redundancy, it's something that you will be able to have. I think this year is going to be really important for CK. You guys have been in the industry for longer, but I think it's insane the amount of people that are working on CKVMs now. The other day we were in the ETH Proofs call, and like at least 10 teams presented or something like that, or maybe more. And I had no idea that some of them existed. I think they're new.
Yeah, I think that the barrier of entry now is considerably lower. I think that uh, we have better resources now. There are like several open source projects. There are like different also design trade-offs and decisions. So some teams decide to explore some of these trade-offs in order to gain an edge over competitors. The good thing is after like several years around, we know what kind of things could work, what things don't. Uh, and it's funny how it has accelerated since the Cairo VM, which was the first one. Of course, it remains to see which one is better. Of course, general purpose seem perhaps the best choice in general, but some of the VMs that have like more customized instruction set architectures and arithmetizations, maybe there you have an edge. I don't know. Maiden VM is one I particularly like uh, because it's rather easy to understand how it works and everything. And it's designed to power Maiden, the Edge blockchain. So I think that is really cool. And to be honest, I really liked the new VM using Venus. At least I think it has like some nice things where you can very easily pack arguments and the opcodes and everything into just one field element. And that's because they are using binary fields that offers like new possibilities. Uh, it remains to be seen whether this is going to be more performant, but at least it's good that they got rid of some of the problems you have when working over finite fields. Binary fields in this sense look way more similar to what we have in computers. So I don't know, it's really nice.
Yeah, I think it's going to be very interesting. And Rig Zero, the second version is using Venus as well, right?
No, I think the one still uses Starks, but probably let's see what they have to announce today at CK Summit. I don't
Okay.
know. We
Bec-
should ask Boris for the latest news. In fact, it should happen like really soon. Let me check.
Because I thought that they made that public a few months ago. Like they say they were working on a Venus CKVM.
Yes, yes, that's true, but I don't think it has been released. Maybe this version 3 either uses B News or Starks. but it's happening at 3:30 Toronto time. So it should be, I think, in 2 hours or so. Yes, in 2 hours. So I don't know, we can catch the stream and see what's going on.
Okay, yeah, I think once we see some announcements, we'll include it in our CK news, and maybe we can comment on what they're proposing next week. I think that will be cool. But yes, I think yeah, this year is going to be very interesting. Everything is moving really fast, and yeah, and Ethereum is doing. I think Justin Drake and the ETH Proof team is doing a good job of uh, productizing a little bit the map of the CKVM ecosystem. So we'll have real time proving really soon. It's going to be closer than I think most people expect. The last thing, guys, I wanted to talk quickly. If you, we talked about this last week in our office when we were on the onsite. With so many teams working in different CKVMs, could you try to explain in simple terms or in a few words what are the main bottlenecks all of these teams found, or like what are the different categories or teams saying, okay, this is actually the main bottleneck for actually having a CKVM, or is this one, and try to give a sense or intuition to people of what is happening and what are people trying to solve. Like the trend of making CK better, what does it mean in simple terms? What are people trying to solve?
Well, the good thing is right now, like one of the main bottlenecks you had in early proving was committing to polynomials. Okay, if you wanted to commit to a large polynomial, you had to do either a big Merkle tree or you had to do a lot of elliptic curve operations. Of course, people soon realized that Starks are really fast for committing polynomials and that you could optimize it quite a lot. And so also with lookup arguments and other things, you could like represent the VM in a more Stark-friendly way. So really, the bottleneck right now for many teams seems to be witness generation. That is to say, generating the trace. So most teams are now trying to solve that because that's the only part you cannot parallelize easy. The others, I don't know, Stark proof generation is really easy to parallelize because you have to do some FFTs, some Merkle trees, and all that, and that is something that you can parallelize. But the execution of the VM, that is not parallelizable. And you cannot like just stop, you have to continue until you have run all the program, and then you would have to send all that information for each of the GPUs that is going to handle, for example, the generation of each part. Okay. So some people, what they are saying is instead of doing that, I can try to run the VM as fast as I can, create like some checkpoints, and just send the checkpoints to the GPU, let each GPU generate like the piece of the trace that they need. And then, of course, communicate and do whatever you need to just uh, ensure soundness and everything. But um, I think that's the main bottleneck many teams have been facing right now. Of course, maybe there are like easier ways if you get like uh, a simpler choice of presentation. Maybe you can avoid some of these things.
Mauro, do you want to add anything?
No, I think that covers it up.
Okay. Now it's me trying to do like the ChatGPT version of what you said, Diego. What you're saying is for people don't know how CKVMs work. When you are executing and trying to prove a program in the CKVM, you generate a trace that is kind of like the footprint of all the execution that happen in the VM. What you're saying is actually generating that footprint that is sequential. I need to do rerun the execution plus adding a lot of information so you can actually then use all of that and generate the proof is what everyone agrees or everyone is trying to solve to make it faster. Like right now, that consumes more than actually the proving in itself, than generating the proving itself. Right?
Yeah, exactly. Because what all the teams have been doing is splitting the program into smaller chunks and proving each chunk and then doing some proof recursion. But um, because that way you can parallelize a lot. But the problem is if you have to run all the program first, and then you can split, that generates a bottleneck because you have to communicate in general from the CPU to the GPUs. So some teams are even going like further and saying, I am going to do everything I can in the GPU so as to avoid this bottleneck in the communication. I think that's the idea, and that is because the witness can be very large. But that shows that, for example, Starks did a terrific job at simplifying proving, because really proving is not necessarily the bottleneck. Of course, there are other steps that may take like some time. For example, proof recursion maybe could be faster. I don't know, some people are proposing using folding schemes to avoid doing full recursion. It remains to be seen. But I remember in Denver, they were already talking about, okay, 80% more or less is witness generation. So if we can improve on that and reduce it, then we are one step closer to real-time proving. Then, of course, there are maybe some things related to a proof system that can be further optimized, but it doesn't make sense if like 80% of your time is just generating the witness.
I think it's very clear. So I think the only team I saw that are doing a competition to help them solve this is Axin, right? And they announced something like it was not an audit competition, or I don't know how to call it, but they're doing a competition in order to help them find
like a bounty.
a bounty program to help them accelerate the trace generation. I think it's quite
Yeah, I
interesting.
think
Yes, there are other teams trying to solve that problem, but I think Saxon was the only one who did it as an open problem.
yeah, other teams were saying we are building our own GPU native CKVM, but maybe, I don't know, some changes in arithmetization can lead to smaller traces. That's another way you can like reduce trace generation time if your trace is way simpler, and you don't need as many constraints. Because I don't know, if you look at the different VMs in general, they have lots of columns that are used to represent, for example, flags, which are just ordinary Boolean variables. And then you have to prove that they are Boolean, so that generates like some problems. I think that maybe with binary fields, some of these constraints are kind of unnecessary because you can enforce them some other way, perhaps. And if you do that, if you can reduce, for example, the amount of registers, the amount of columns in your trace to, I don't know, half, that already is a significant advantage, because this implies like, okay, you have half the number of FFTs, half the witness generation time and everything.
Yeah. I don't what I don't know if it proofs, for example, they are tracking all of this. Do you know if there's any place where you can track uh, the latest advancements on these bottlenecks? I think there's still some work that needs to be done to put this more
No.
publicly and accessible.
Thing is like this assume like this is probably not the bottleneck for most VMs. This is like the bottleneck for the fastest VMs,
Ah,
right?
okay,
You need to be very fast in order to get that problem. But before that, you are stuck in the old problem, right?
okay. So but that's an engineering problem, Mauro.
This is a pure engineering problem. Yeah, for me, that is a match solution on the cryptography side. And it's a problem because your machine runs sequentially. Like you don't have parallelization. Proof parallelization is more expensive. Then you need to write all this data. Is very traditional engineering. I think one of the proposed solutions was to kind of checkpoint the the trace, like to have like less logs. Let's
Mm.
say like if you prove a lot of logs or a lot of rows in a trace, but you can imagine it as the different logs, like deleting some in the middle and then trying to reconstruct them in parallel. But it's very very engineering like.
Yeah, I was looking at ETH proofs, and right now it seems that to prove blocks more or less, it takes for the fastest VMs around 3 minutes and 30 seconds, and the average cost per proof is around 5-6 cents per proof. So that's super interesting, and I think they are going to add a bit some new VMs. CK MIPS apparently is way slower still. They are on the order of 11 minutes. But I think that these costs will go down at least significantly. I think that still we can get a 2x or a 3x. And it's not even necessary to be able to generate like the proofs in real time. It's enough just to be able to keep up with block production. So if you have like several GPUs in waiting, you can keep up with the production. You will have a delay maybe of 3 minutes, 4 minutes, but that doesn't matter really that much. Um, of course, if we could do it in less than 12 seconds, it would be great, but I don't think we are getting there anywhere close. No, we would need
And
more than a 10x.
if we go by the proposed roadmap of Ethereum, like we will have an advantage. Like if every time that we will run the EVM inside the EVM, that's part of the proposal. So it might be a RISC-V VM inside the EVM or RISC-V VM inside a RISC-V VM, whatever. Those are kind of independent executions of the VMs, so you can generate a trace of them in parallel. So that should you could add more of those independent threads of other VMs without impacting like proof time, at least from the perspective of the trace generation. But it's a long road until that.
Um, okay. I think we can talk more about real-time proving next week and explain better what it is and some of the math behind adding GPUs and all of that. I think we have been learning a lot about provers. Not on, I mean, you guys know a lot about the technical side, but lately on the actually using many of these solutions, the team was lucky to play around with many of them, and at the same time had to suffer many of them. So I think it's going to be interesting to share more about that. Yeah, and I think we cover almost everything today. In, next week we can dive into more stuff.
Yeah, probably the only news that we missed was the MITEM VM and the results that they have. Very interesting.
Because they published by the end
Yeah,
of the week some new results. That's true, and they are faster than SP1, right? For many.
it depends. The thing is that SP1 and Rexito, they have been focusing mostly on proving Ethereum, which is a much different problem for local
Yeah.
proving, and things that you need to have something like a private network. So the results shows more or less that, yeah, if you're trying to prove something like Ethereum or big programs, uh, of course things like SP1 and maybe even Reach0 may be better. But for the case of having to prove small things like signatures to execute transactions and that kind of things, which are not so long, but you need them to be very fast because it's not a very good user experience to wait 20
Yeah.
seconds in your phone or half a minute in your phone. In those scenarios, they are better, which is very nice because if we want local proving, we need some things that they don't consume much RAM and they go really fast. And they don't need to support like very complex proving patterns like a full lock of Ethereum or things like that. They are mostly just signing stuff, proving to approve transactions and that kind of stuff. So it's a very bounded room of programs.
Yeah. So it's easier to understand what you need to optimize, right?
That's right.
Yeah. I think we should talk more about Maiden as well. Probably the most interesting blockchain, if we can call it a blockchain. I'm not sure if it's 100%, 100% a normal blockchain. Um, I think it will be cool. And at some point, if we could have on a Wednesday someone from their team like Bobin, it would be fun having you
Yeah,
guys talk with him.
last week we had Paul talking with Boris, I think, or
Yeah.
the other week. But chatting with one of the guys is always like super fun. Besides, you learn a lot by
Yes.
talking with them.
Well, we also have like Aztec tested, so it's like true privacy networks moving forward.
Yeah. Okay. Well, we'll
Okay.
close here, everyone. Thank you for your time. We'll see you next week.
See
Bye bye.
you.
Goodbye.